Let's now look at a few examples where we're going to use the sum and difference formulas. However, in this case, instead of relating it to our unit circle angles, we're going to be talking about trig functions of any angle. Here, it says, find the exact value of the trigonometric function given that sine of u is equal to negative 7/25 and cosine v is equal to negative 4/5. Both u and v are in the third quadrant. All right, and we are asked to find the tangent of u minus v. Well, notice we have a difference within a side of our tangent function, which means we want to use our difference formula for tangent. The tangent of u minus v is equal to the tangent of u minus the tangent of v divided by 1 plus tan u tan v. Well, we've got our formula, but in order to use the formula, we must know the tangent of u and we must know the tangent of v. And we don't have either one of those quantities. However, we do have enough information to draw out each one of these angles, u and v. Let's talk about u. We know that the sine of u is equal to negative 7/25. We also know that the angle is in the third quadrant here. And our definition for evaluating sine, when we're not talking about the unit circle, for trig functions of any angle, the sine of u is equal to y over r. This means when I draw out this angle in the third quadrant, the y-coordinate associated with the endpoint has to be negative 7, and r, the radius of the arc, has to be 25. All right, so we can draw out our angle, and there is our angle u. Similarly, we could do the same thing for the angle v. We know that the cosine of v is equal to negative 4/5, and that the angle is in the third quadrant here. Our definition for evaluating cosine of angles that are not on the unit circle is the ratio of the x-coordinate divided by the radius of the arc. All right, so I know that x has to be negative 4 because we are in the third quadrant. X is going to be negative 4. R, the radius of the arc, is going to be 5. Again, remember, r is always positive. R is a distance. Only x and y will be positive or negative, and that's going to depend on the quadrant that we are in. Okay, so here we have the angle v. Well, if we're going to find the tangent of u and the tangent of v, that means we need to identify the remaining ordered pairs, all right, or sides of our corresponding right triangles. We can find the x-coordinate here associated with u by using our Pythagorean theorem. We know that x squared plus a negative 7 squared has to equal 25 squared. Doing out our algebra, we get x squared is equal to 576, which means x is equal to negative 24. All right, don't be afraid to plug those into your calculator. Just double check. Notice that x is negative because this angle is in the third quadrant, right? We are going to the left, therefore the x-coordinate must be negative 24, right? So we're going 24 units to the left, 7 units down, and that gives us our terminal side for our angle u, the endpoint of our terminal side of angle u. All right, we can do the exact same thing over here with angle v. We need to find this side of our corresponding right triangle, the y side. Well, negative 4 squared plus y squared is equal to 5 squared. That means y squared is equal to 9, and y is equal to negative 3. Again, y must be negative because this is in the third quadrant. We are going downward from our x-axis. So now that we have drawn out each one of our angles, we've found the corresponding x and y coordinates associated with the endpoints of their terminal side, we can finally use our formula. Tangent of u minus v is equal to tangent u minus tangent v over 1 plus tan u tan v. Well, the tangent of u, to evaluate the tangent of u, tangent of the angle u, that's our y-coordinate divided by our x-coordinate, negative 7 over negative 24. Notice both are negative. This is just going to give us 7 over 24. And the tangent of v, well, tangent of v, y, negative 3 divided by negative 4. Negatives over negatives cancel out, and we're left with 3/4. So plugging this into our formula now, we have 7 over 24 minus 3 over 4 divided by 1 plus 7 over 24 times 3 over 24. Now we can begin to simplify. Well, if we're going to subtract the two fractions in our numerator, we have to get a common denominator. We can multiply this fraction by 6 over 6. That will give us a common denominator. 7 minus 18 leaves us with a negative 11 over 24 in the numerator. When we multiply out our denominators, to multiply out these two fractions, we multiply across. Notice 7 times 3, well, 7 times 3, that's going to give me 21 over 24 times 4. That's going to give me 96. And we can reduce that into 7 over 32. I've got negative 11 over 24 divided by 1 plus 7 over 32. One trick, guys, make sure you are comfortable plugging in fractions into your calculator, okay? You will have a calculator for this, so don't be afraid to just plug in 7 divided by 24 minus 3/4, and then use the math frac feature of your TI-84. Anytime you plug in and get a decimal approximation, you can hit math and frac, select frac, and it will automatically, if possible, turn that decimal approximation into a fraction. All right, so you can get these simplified forms of these fractions. Well, we can continue to simplify our answer here. 1 plus 7 over 32. Again, we could get common denominators. 32 over 32 plus 7 over 32. That gives me 39 over 32 as my new denominator. Dividing by fractions, well, we can think about that as multiplying by reciprocals. And again, don't be afraid, plug this in your calculator, use the math frac button, and it will simplify that fraction for you. We get negative 44 over 117 as our final answer. All right, again, make sure you know how to use your calculator. However, do not give me decimal approximations when it specifically says find exact values. Okay, negative 44 over 117. That is an exact value, not a decimal approximation. Let's try another one here. Find the exact value of the trigonometric function given that sine u is 5 over 13 and cosine v is equal to negative 3/5. Both u and v are in the second quadrant in this case. Find the secant of v minus u. Now notice, this one is asking us to find the secant. There is no sum or difference formula for secant. However, we can begin by finding the cosine of v minus u, and then take the reciprocal to answer the question. Yes, cosine and secant are related in that they are reciprocals of each other. So if we know what the cosine of v minus u is, then we can figure out what the secant of v minus u is. Well, here's the formula. Cosine u minus v is equal to the cosine of u cosine of v plus sine u sine v. Notice the only difference here, we need to swap out the location of our u's and v's. That means the cosine of v minus u is what we're looking for in this case, is going to be cosine v cosine u plus sine v sine u. Well, cosine v. We've got cosine v. That's a good thing. Cosine u. We don't have the cosine of u, but we do have the sine u, and that gives us enough information to draw out our angle. We know that the sine of u is equal to 5 over 13. Our definition for finding sine is y over r. We know that this angle must be in the second quadrant. That's given information here. Okay, so we can draw in our angle. We know that the corresponding y-coordinate has to be 5. We know that the radius of the arc has to be 13. We can do the exact same thing for our angle v. Cosine of v is equal to negative 3/5. Well, our definition for cosine is x over r. We are in the second quadrant again, so we know the x-coordinate has to be negative 3. R, the radius of the arc, has to be 5. We can now use the Pythagorean theorem for each one of these to find the missing sides of our related right triangle. In this case, we would have x squared plus 5 squared is equal to 13 squared. X squared gives us 144. Taking the square root, we get x is equal to plus or minus 12. Because we are in the second quadrant, we know that the x-coordinate must be negative. Therefore, our x-coordinate is going to be negative 12 for our angle U. We can do the same thing over here. All right, for our angle V, to find the corresponding y-coordinate. Negative 3 squared plus y squared is equal to 5 squared. Y squared is equal to 16, and y in this case is positive 4. Notice we want the positive root because our angle is in the second quadrant. All right, now that we have both of our angles drawn out, we have all the corresponding sides, our ordered pairs, x's and y's, we can now use the formula. Cosine v cosine u plus sine v sine u. Well, the cosine of the angle v. Here's my angle v. Cosine is x over r, negative 3/5. Cosine of u, x over r, times negative 12 over 13, plus the sine of v. Well, the sine, that's y over r. That's going to be 4/5 times the sine of u. Y over r, that's 5 over 13. Negative 3/5 times negative 12/13 plus 4/5 times 5 over 13. We can now begin to simplify. Plug this into your calculator. Well, negative 3/5 times negative 12 over 13, it's going to give us a positive 36 over 65 plus 4/5 times 5 over 13. That gives me 20 over 65. All right, notice that I didn't actually simplify that one fraction because the nice part here is we end up with a common denominator. I guess if you're using a calculator, not that big a deal, but if you're not using a calculator, it'll make your life a little easier here. All right. And so now to add these two fractions, all we have to do is add our numerators. We end up with 56 over 65. So this is the cosine of v minus u. Notice that what we were looking to find was the secant of v minus u. Well, cosine and secants are reciprocals of each other. That means to get the secant of v minus u, I just need to take the reciprocal of this fraction, 1 over 56 over 65. And the shortcut for that is just to flip it. The secant of v minus u is equal to 65 over 56. All right, so there we have some uses of our sum and difference formulas for angles when we're not specifically on the unit circle. All right, but don't forget, when in doubt, draw it out. Don't be afraid to draw pictures when you are dealing with trig. We can draw out each one of the given angles based off of the information that we have, and that will allow us to then utilize each one of the formulas.